All right, so we're investigating some horizontal asymptotes, and we're going to talk about them and as they relate to rational functions. So just as a quick reminder, rational functions were written like this. A rational function r of x would be a polynomial function p of x on top and a polynomial function q of x on the bottom, where q of x is not the zero polynomial, right? So this is just when q of x is not going to equal 0. Obviously, we talked about the domain of these. We talked about vertical asymptotes. We graphed them. We talked about x and y intercepts. And we can make a graph of those. But horizontal asymptotes actually came up when we graphed them. And so I just want to talk about the different categories that they could be, right? And why they occur, or where they occur. Not necessarily why yet, but where they occur, right? And there's going to be 3 different categories. And so what we really need to look at is the degree of the numerator. We need to look at the degree of the numerator and the degree of the denominator. So the degree of numerator n and denominator d. All right, so that's just how we're going to refer to them. The degree of the numerator and the degree of the denominator in ours. So let's see here. Let's try to draw a straight line here. It's pretty straight, I guess. Kind of, maybe? I don't know. All right, so the first category would be when the degree of the numerator is less than that of the denominator. So as an example, we could have, let's just write an example here. Let's make one simple. So like, what if we had 4x squared plus 3x plus 1, all right? Simple, no big deal. If that's the numerator, the degree is 2 right here, right? So if the denominator is bigger than that, like the degree of it, so x to the, had to be anything bigger than 2, so like 4, I'll just make some other stuff up here, plus 5 maybe, okay? So, and this is an example where n, the degree of the numerator, is less than the degree of the denominator. When that happens, in any situation where that happens, you're going to have a horizontal asymptote. So horizontal asymptote at y equals 0, which is actually just the x-axis, all right? So if you're following this and you're trying to learn from it, you probably should have paused and written this down. Make sure you investigate that. Rewind if you don't understand it, okay? Second one. Is that a straight line? Is that a straight? Well, whatever. Okay, number two, or category 2. So this is when n is less than d. What happens when n is equal to d? Meaning the degree of the numerator is going to be exactly the same as that of the denominator. So let's say we have like 2x cubed plus x squared minus 1 over 3x cubed. So the degree is the same, minus 7x squared plus 12, let's say. Let's just suppose, right? So if that's the case, it turns out, this is actually a really simple situation too, it turns out that the horizontal asymptote, so now there's a horizontal asymptote, I'm just abbreviating, horizontal asymptote at y equals 2/3. Now where did the 2/3 come from? Well, that is those are the leading coefficients. This is the ratio of the leading coefficients. So look at the highest degree, which tells, or the highest exponent, which tells you the degree. What's the coefficient for that? So if there was no number there, it would be a 1, right? So if this was just x cubed, it would be 1. And then what's the number in front of the x cubed here? It's a 3, so it's 2/3. There's a horizontal asymptote at 2/3. And you could verify that. You could pull out your graphing calculator, you could plug that in, and then you would see a horizontal asymptote at y equals 2/3. All right, those two are pretty simple. These are not too bad. The third category, however, starts to create some problems, because when n is not less than d or equal to d, but greater than d, the degree of the numerator is bigger than the degree of the denominator, we're going to have some issues. So like, let's say we have 4x cubed plus 2x minus 10, let's say. And we divide that by something that's of a smaller degree, lesser degree, so like x squared, right? Plus 1, let's say. If that is the case, there is no horizontal asymptote. So there's no horizontal asymptote There's no horizontal asymptote. However, there are special cases here. Because really this is a category that needs to be broken up into subcategories. Really what happens is if the degree of the numerator is just one bigger than the degree of the denominator, you can actually divide and you'll get a oblique asymptote. So there could be a graph, right? Could be a graph where we don't have a horizontal asymptote, but we do have an oblique. An oblique asymptote is where it's diagonal, right? Diagonal. Now there's other types of asymptotes that you could have. Typically in pre-calculus, you'll mainly just study the vertical and horizontal, and then you get to the oblique ones. You could use different types of division. So you could actually divide these polynomials. Some people learn synthetic division. Some people learn just straight long division. Some people learn how to do it with the boxes, right? Where you would put x squared and 1. You would try to divide all this stuff up. There's whatever way works for you, but you're going to come up with special situations when n is greater than 0. Or I'm sorry, n is greater than d. That does look like a 0, doesn't it? Good luck with all that.